the concentric circles left by the tooling, and the surface of the lens is rough. So, they polish it, using abrasive paper under water heated precisely to 19 degrees Celsius. The water temperature must be constant, or else the lens will become deformed. Now that the lens is perfectly shaped, they remove the metal attachment. Then peel off the protective film on the other side. Using a machine called a lensometer, they make sure the prescription is accurate. Next, the lenses go through an automated 15-stage chemical cleaning, then are coated with varnish to make them scratch-resistant. They go into an oven for 3 hours until the varnish cures. Next comes the anti-reflection treatment. This will increase the lens's transparency, allowing in more light. The lenses go into a chamber. They add different powdered chemicals, such as silicium oxide, titanium oxide, and zirconium oxide. They close the door, then pump all the air out of the chamber. Using a high-powered electron beam, they heat the chemicals to the boiling point. The powders transform from solid to gas, coating the lenses in the process. It's finally time to fit the lenses to the frame. They position a suction cup on the lenses to hold them in place during the fitting. An automated machine traces the shape of the frame, then cuts the lenses to that shape. With regular frames, the lenses simply pop in. To attach ultralight metal frames, they drill holes right through the lenses. From plastic disc to the latest in eyewear in just 3 days. What do you get when you cross a spider with a goat? A silk fiber stronger than steel, yet more elastic than nylon. Canadian researchers implanted a spider's web-spinning genes into a goat's mammary glands. The result? Goat's milk with silk proteins, the raw material for a fabric strong enough to be bulletproof. Granite is one of the strongest stones on Earth, and it's the darling of decor these days. As an indoor-outdoor building material, it's timeless, elegant, and resistant to acid rain. Nature's granite factory lies many kilometers beneath the Earth's surface. Boiling molten rock called magma builds up pressure from the intense heat and rises through cracks and crevices in the Earth's crust. As it rises, it slowly cools and solidifies into granite. Most granite is buried under sedimentary rock, which makes up most of the Earth's surface. The challenge is to extract as much granite from the quarry as possible, while losing as little as possible to damage from the extraction process. They start by outlining a section of rock wall, up to 30 meters long by 7 meters wide. They use a gas flame to burn long, narrow channels to free up the sides. Then they drill holes 7 meters deep along the back and bottom. They feed explosive cable into the holes. Then they set it off. The explosion detaches the section. Then they use a combination of drills, steel pegs, plates, and wedges to cut it down and cut it down further until they have rough blocks measuring 3 meters long by 1.5 meters wide and deep, a size the granite factory can handle. The blocks may be small, but each one weighs more than 20,000 kilograms. At the factory, the first cut is called slabbing. They use this type of saw to cut slabs more than 5 centimeters thick. The blade's metal segments contain synthetic diamond particles, which create the friction needed to make the cut. Water keeps the saw from overheating. It's a slow process. The saw cuts less than 2 square meters of granite per hour. They use a gang saw to cut slabs thinner than 5 centimeters to make kitchen countertops, for example. This saw has steel blades, tense enough not to bend under the pressure of cutting, and calibrated to cut as straight as possible. The gang saw cuts at a rate of about 8 square meters per hour. It takes 3 entire days to cut through the rough block. Once a slab is cut, it goes for polishing. This is what will bring out the beauty of the stone. The polishing line has 19 heads, each of which has 6 bricks that polish by abrasion, like sandpaper. The brick grains get progressively finer as you go down the line. The polishing line processes about 1 square meter of granite per minute. For a high gloss finish, a slab goes through all 19 heads. For a semi-gloss finish, it goes through just the first 10 heads. For a rough finish, slabs skip the polishing line altogether and instead go through a process called flaming. With a stream of water to keep the slab from cracking under the heat, they run a propane flame at 2,000 degrees Fahrenheit across the surface. This intense heat makes the quartz inside the granite explode, creating a rough surface. They often use this technique for non-slip flooring. After the finish, the last step is to cut the slabs to specifications. Granite is composed of various minerals. They're interlocked like pieces in a jigsaw puzzle, giving the stone its trademark speckles and its remarkable strength. They say chips were invented when someone sent back his fried potatoes, complaining the slices were too thick. The insulted chef cut them paper thin and fried them to a crisp. So pride, not necessity, was the mother of this invention. Potato chips have since become the consummate snack food. They have to be made with fresh potatoes, no more than 24 hours old. Otherwise, the chips will have black spots. After a brushing machine removes the dirt, the potatoes travel along a water canal to the peeler. They tumble around and around against the peeler's abrasive rollers until the skins come off. This machine can peel 12,000 pounds of potatoes per hour. Next stop, a machine that separates the potatoes by size. The small ones fall below to be rinsed. The larger ones stay on top to be cut. Then they fall down to the rinser too. Next, the potatoes go through slicers. The slicer's blades are adjustable. They can be set to different thicknesses or to different shapes, to slice ripple chips, for example. The centrifugal force created by the spinning throws the potatoes against the sharp blades. To make regular chips, they cut slices 6/100ths of an inch thick. An average potato will yield about 36 chips. Finally, it's time to wash the potato slices. They spin inside a giant barrel of cold, fresh water for about a minute. Then, like at the car wash, the slices pass under an air blower to dry up the excess water. The fryer contains canola oil boiling at 375 degrees Fahrenheit. It takes just 3 minutes to fry the potato slices into potato chips. As the chips exit the fryer on the conveyor belt, the excess oil drips off. Next, a shower of salt. The chips then move on to the sorter. An electronic camera identifies any chips that have brown spots or other defects. The camera then triggers the thin pipe directly above that bum chip to blow it off the conveyor belt with air pressure. Elsewhere in the factory, they're making another popular snack food, cheesies. They take corn flour and mix it with water. An extrusion machine forces the mixture through round holes. When the snake-like streams come out the other end, a knife cuts them into pieces. The heat in the machine then causes the flour in those pieces to explode, creating slightly curled puffs. They spray those puffs with a mixture of canola oil, powdered cheese, and natural colorings. A revolving drum mixes it all together. Back in the chips department, they spray the potato chips with powdered seasonings, which simulate flavors such as barbecue or salt and vinegar. The next machine separates and weighs the portions to be packaged. The chips drop into bags that are then heat sealed. It's taken about 15 minutes to go from raw potato to potato chips. A lot longer than it takes to eat them. A microprocessor is the brain inside a computer. It's made up of a microchip on an electronic card. Preparing the chip to be installed on the card is a delicate and precise operation. Scientists built the first computer in 1937, but it could only do algebra. The first general-purpose computer in 1946 was the size of 20 refrigerators. During the 1950s, transistors replaced bulky vacuum tubes, then integrated circuits replaced transistors. But the biggest breakthrough came in 1971 with the microprocessor, all the components on one minuscule chip. That's what made the personal computer possible. They start with a ceramic square called a substrate. This will carry the microchip. A machine coats the substrate surface with flux, a chemical that makes it sticky. This will hold the microchip in place until it's soldered. The factory receives the microchips ready-made, with all the circuits in place. They place a microchip on each substrate. An infrared light guides the machine to place the chip in precisely the right spot. They pull a sample from the production line to further verify the positioning with a microscope. Next stop, a soldering oven at 365 degrees Celsius. The heat melts tiny beads of tin positioned on the chip, binding it to the substrate. Next, they prepare to solder an aluminum cap over each microchip. The cap will have two functions: to protect the chip and to dissipate the heat the chip generates. A robotic arm picks up 4 caps at a time and positions them over the microchips. They go into a soldering oven at 150 degrees Celsius for about an hour. The next step is to create the electrical connections that will later link the microprocessor to the computer's electronic card. They start with tiny cylindrical pieces of tin called columns. Tin conducts electricity. A giant suctioning sieve vibrates the columns until they fall through the holes. This lines them up vertically so that they can be attached to the substrate. A machine spreads a thick adhesive paste, then attaches the vertical columns in it from underneath. A robotic arm positions the chip-carrying substrate onto the pasted columns. The result is a microchip with 1,000 connections. For even more connections, they use tin balls instead of columns because balls are sturdier and more reliable. They too go through a suctioning sieve, only instead of paste, they're stuck on with flux, that sticky chemical used earlier to position the microchip onto the substrate. The finished microchip unit goes into a bath of water and solvents to remove any excess flux or other residues. Last stop, quality control testing, up to 12 hours in an oven heated to 140 degrees Celsius. From here, the microprocessor unit goes to another factory where it's soldered onto an electronic card, which then goes into a computer. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.